Hello everyone, in this lesson we are going to learn about loops in R. So by the end of the lesson, you will learn how to automate repetitive tasks in R. Loops automate repetitive tasks by iterating over sequences or conditions. And these are the various types of loops in R: the for loop, while loop, and repeat loop. And in this particular video, we are going to learn about the for loop. So the for loop iterates over elements of a vector or list. And so this is the syntax. You would write the for function, and within the parentheses, you would write item in collection. Now take note, the item is a placeholder that takes the value of each element in the collection. You can name it however you want. So programmers would often write for I in collection, for K in collection. So you can give whatever name in place of the item in this particular syntax. The collection can be a vector or list that you want to iterate over. The in word is a keyword in R that links item to every single element that is found in the collection. So after writing the body of the for loop this way, you open a set of curly braces and you would write the code to do something with item. So let's go to R and demonstrate how to create for loops. Now let's go ahead and write our syntax right here so that we can follow through to create our for loops. So if you remember from the slides, we have for item in collection. Then in the set of curly braces, you write the code to do something with item. Let's go ahead and highlight these lines of code. Press Ctrl-Shift-C on your keyboard to comment everything at once. Now let's create our first for loop. So let's go ahead and say for I in 1 to 5. Then we open the set of curly braces, and within it, we write the code to do something. So let's say print I. Now let me explain this to you in very simple ways. So this item in the syntax is just simply the I. If you recall, we said you can name it however you want. It doesn't matter. So it wouldn't even matter if I go ahead and write for item in 1 to 5, for number in 1 to 5. Whatever you put there is actually going to work. So you can name it however you want. It's a variable, a placeholder. Then we have the in here, which is a keyword that links this I to every single item in this vector. If you recall, it was the collection, and we said a collection can be a vector or a list. And in this case, we simply have a vector. So if I highlight that code and click on run, you see that we just simply get the numbers 1, 2, 3, 4, 5 in that vector. So inside a set of curly braces, what do we actually want to do with each value in this collection? We just simply want to print it. Let's now highlight these codes and run them. And you do realize that every single number that is in the vector would actually be printed to the console in that specific order. So simply put, just think of it as saying for each item in this particular collection, do something with it. And in this case, we are just simply printing each item in this collection. So that is our first for loop. Now let's go ahead and, for example, create a variable called x, and let's create a vector with some arbitrary set of numbers. So like 2, 9, 10, 15. And then we go ahead and run this code. Let's clear the console. And then we can now write a for loop to do something with this vector. So then let's go ahead and say value in x. And remember, this x is this vector containing 4 items. So for value in x, what do you want to do with each of the value that is found in x? So let's go ahead and say that we want to square every single number that is found in this collection and print the result. So we have for value in x, print value squared. Highlight the code, click on run, and you realize that each number has been squared. So we have 2 squared, that gives you 4, 9 squared, that gives you 81, and so on. Now let's go ahead and do something like names, and let's go ahead and have a vector of, let me use my name. So my first name is Elijah, and my surname is Apia. Let's run to execute this. And then we create a for loop to do something with this name. So let's go ahead and create a simple greeting for each name that is found in the vector. So I'm going to actually name my variable here as name in, and then the vector is names. So it rhymes for name in names. So it is much important to choose meaningful variables or placeholders for the very first item that you put into the for loop, the body of the for loop. So for name in names, for value in x, and then for I in 1 to 5, whatever you actually want to call it. But make sure that the variable names are much more meaningful. So let's go ahead and do something with each name that is found in the vector of names. So let's go ahead and use the paste function. And then for the very first value, I'm just going to write hello. And then afterwards, I will just bring name. So this name is what gets placed here. So what is actually going to happen is this name is going to be assigned Elijah first, and that will get deposited here so that we have paste hello name. So we are simply going to print the result. So let's bring the print function like this. So just like we said, name is going to be Elijah, then Elijah gets placed here. So hello Elijah is going to get printed. Then it goes back to the body of the for loop. Name will hold the second value in the vector, which is appear, and then places that appear right here and say hello appear. So let's go ahead and run this here and see the result we get. So we get hello Elijah, hello appear. This time, let's go ahead and create a matrix called A, and then the data is going to be set to 1 to 9. The number of rows should be 3, and the number of columns should be 3. So we are simply creating 3 by 3 matrix. Let's get the console first. Let's print the matrix A, and this is what we actually get. So what we want to do with the for loop is we just want to loop over every single column that is found in the matrix, and we want to return every single column all at once in the for loop. So I will go ahead and say for, then let's use a meaningful name. I will say COL to mean column. So for column in, then we have the number of columns. Okay, so for example, how many columns do we have in the matrix A? We have 3 columns, 1, 2, 3. So I'm just simply going to go ahead and say 1, 2, the number of columns in A. I hope you get this point. So number of columns is a function that will return how many columns there are in a particular data structure like a matrix. So for example, if I go to the console and write ncol and then put in the matrix A, we simply get 3 because we have 3 columns. We also have another function called the nrow, which will also return the number of rows. So if I put in A, for example, we also get 3. And that is because we have a 3 by 3. And if you recall the lesson on matrices, we even have the dim function that actually checks the dimension of the matrix, which is just 3 by 3, 3 rows and 3 columns. So that is why I'm using the ncol. So actually, I could have gone ahead to say that because I can actually count this easily and know that there are 3 columns, I could have gone ahead and replaced this one with 3 like this. So for call in 1, 2, 3. All right. But sometimes we just simply want to use meaningful functions that make sense to the reader or anybody that actually has access to the code and wants to understand what is being done. So we have for each column in 1 to the number of columns in the matrix A, we want to do something. So let's go ahead and print. And if you remember, if you actually want to index a matrix, like call out elements from within a matrix, we initiate the square bracket after the name of the matrix, and then within it, we specify the row, comma, column. So for the row, because we're actually returning the columns only, I'm not going to put anything for the row, so that's going to be empty. Then comma. Then for the column, I'm just simply going to go ahead and put COL, which is the variable that we specified in the body of the for loop. So this is actually what is going to happen. Now this 1, 2, ncol A will actually return sequence of numbers from 1 to 3. For example, let's go to the console. Let me actually execute it from here. So I highlight this part of the code, click on run, and you see that we just simply get 1, 2, 3. So what is going to happen is COL, which is the variable name here, call, is going to assume the very first value, which is 1. And then it will deposit that 1 right here. It will place it in place of this call variable that we have in the matrix indexing. So that is going to be all rows and the first column. Then it goes back to the body of the for loop. It now takes the second value, which is 2, and then it now places the value 2 right here. And so it's going to print the second column. So let's go ahead and print the matrix A in the console. And now we can execute this for loop, and then we see that 1, 2, 3 happens to be the first column, and these are the values that are printed. 4, 5, 6 being the second column, that is also printed right here, and then 7, 8, 9, third column, that is also printed here like that. So when you understand for loops, you can actually do much more complex things. Now let's get more complex. So I'm going to go ahead and create a vector called numbers, and in that case, I'm going to put in values like 10, 20, 30. Let's execute this and now create our for loop to do something with each number in the numbers. So I'm going to go ahead and say for, and then I would write for number in numbers. That makes sense, right? Now, what is actually going to happen is if I go ahead and say print number, it means that we are just simply printing every single element that is found in this collection. So we have 10, 20, 30. But this time, this is actually what I want us to do. We do have, for example, just like we did with the matrix up there, I could say for number in 1 to the length of numbers. Now remember that length is also a function that is going to check how many items we have in a data structure. For example, a vector like this one. So if I click run to execute that part of the code I've highlighted, you see that we get a result to be 3. So again, this is just simply 1, 2, 3. Very simple, right? So for number in 1, 2, 3, and in that case, I just simply wanted to put in place the length of numbers so that if you go ahead and extend the list, it will always be the length. That is how many items that we have in this particular vector. So 1 to 3. So if I go ahead and actually say 40 like this, that means still length of numbers is still going to return the number of items, which happens to be 4. So let's execute this part of the code again since I appended the number 40. So for number in 1 to 4, that is the length of numbers, then there is something that I want to do. I want to use the cat function. If you recall, we have learned about this concatenate and print function. And what I want to do is I want to print something that we call index. Now, remember we said that this number here takes every single element that is found in this collection that we have specified here and then goes through whatever is found here to do something with it in the body of the for loop. So in that case, let's go ahead and say index colon, and that is going to be number. So we know we can track what is actually happening. So I would say I would say number because we do have number right here. So index is going to be the number. So we know what number is doing in the background. And then when we finish, we'll go ahead and now return the value itself. So I would bring the text here and then what is going to be the value? The value is going to be every single element that is found in the numbers vector. So I would write the numbers vector and then we have the square bracket. Remember how we index vectors, and I'm going to put in number. Now, if this numbers number is quite confusing to you, I just simply want to go ahead and change this number to say I. So I'm going to say for I in 1 to the length of the vector numbers, index the I, then the value should be the numbers vector, and then we call out the ith element within the vector. I think this now makes sense, right? Making it very simple if the numbers is quite confusing. So in this case, let's go ahead and execute this for loop and then see what we get. So if we execute this for loop, we now have index 1, value 10, but we can see that all of them have been put together in a way that doesn't look so much appealing. That is because the cat function is doing something in the hood. And all you have to do is just remember when you are dealing with strings, you can bring some special characters like the \n to print new lines. So I'm just going to extend this cat function and then bring another character, and within it, I'm just going to write the \n. And so that is to say that I is going to be equal to the first value, which is 1 in the body of the for loop. So index is going to be I, like we have here, and that is going to be 1. Then the value is going to be numbers. Then this I, remember, has taken the value of 1, so it puts it here. That means numbers square bracket 1 means call out the very first element in the vector. Then it goes back to the for loop again, and I is going to assume the second value, which is going to be 1, 2. Remember, length of numbers is 4, so it's going to be 2. So index 2, and then when 2 gets placed here, we are calling the second item from within this vector. It's very simple if you are following this. So just simply by bringing this \n inside of the cat function, it's just now going to actually break these texts into each own line. So let's go ahead and execute this line of code and see what we get. So if we run this, we now get index 1. So when I is 1, it goes ahead and dumps that 1 right here to return the very first element of the vector, which is 10. So index 1, value 10. That is what actually happens. Then I is going to assume the value of 2. So index 2, value 2 here means the second item in the numbers vector, and that is 20. And that is what actually is happening. So when you use the cat function, these are some of the petty things that you need to take notice of. Otherwise, you may be getting certain outputs that may not look so appealing to you. And in that case, you could have actually dodged this here by simply using the paste function. But remember that the paste function actually returns the text in quotes. And sometimes it just looks something else because of the quotes. But don't worry, if you are comfortable with it, you can actually do it. So in this case, we would say paste, and then you have to print it actually. So when you're using the paste function, you have to actually print it in the for loop. If you don't bring the print function, nothing is going to get printed for you. So we have index I value, everything is going to be the same, but this time we just change the function to paste. And then if we go ahead and run this, we now get index 1 value 10, index 2 value 20, and so on. But this time you can see that they are put in quotes. And if that's something that you don't like and you want just the raw text itself, use the cat function. We explained this in a video before. Now let's go ahead and do something a little more complicated. The for loops is getting interesting. Okay, so let's say that you actually want to build nested for loops. So a loop inside of a loop. So now let's start with for I in, let's say, 1 to 3. And then you open the set of curly braces, press enter, and then move into the indentation, the next line. And I'm going to insert another for loop and say for I in 1 to 2. And then let's also open another set of curly braces, press enter. And then within it, what do we want to do with the I? Sorry, because we are using the variable I, it is not advisable to use the same variable name. So I'm going to change this one to J. So it reads for I in 1 to 3, and for J in 1 to 2, just do something with the I and the J. So all I'm going to do right now is use the same cat function, and I am actually going to return every single element that is found in the collections referring to the I and the J in the for loop. So let's go ahead and write a text and say I like this, and maybe do equals, and then after that comma. So we have a text, we are concatenating and printing. So I equals I. And then again, let's also have J. So let's have comma, for example, J equals, and let's have J, right? I think this is very easy. So let's bring another character. Remember, we have to insert a new line just like we did up here. Otherwise, it's actually going to put everything on the same line. We want each one of them on its own line. So new character or new line, sorry. All right, so let's see what is actually going to happen. It means that I is going to assume the very first value, which is 1. Now, this 1 is going to get distributed over the elements in the for loop. So I is going to be 1. Then it comes to the second for loop. J is also going to be 1. So the first thing that will be printed will be I equals 1, J equals 1. And that is what we are doing here. So the text I equals 1 here, and then J equals 1 here. Now, this same 1 will still be holding in the for loop. It has not finished running. Then this J will now take the second value, which is 2. So this I will still remain as 1. So I is going to be equal to 1, but the J is now going to be equal to 2 until the J exhausts the number of items in this particular collection, which is 1 to 2. Then it goes back to the first for loop. And now I is going to assume the second value in that collection, which is going to be 2. So if I equals 2, then J would be 1 again. So it will be 2, 1. And then whilst I remains as 2, J is also going to be 2. So it's going to be I equals to J equals 2. Then again, it goes back to the first for loop. And again, I is going to be equal to 3. All right. So it is in that very order. And that is why I had to use this cat function to show you exactly what is happening under the hood. So if I go ahead and execute this, you would see that I equals 1, it holds it. And then J equals 1. I equals 1, it holds it, then J equals 2. Then it now moves to I equals 2, then J is 1, J is 2, whilst I remain 2. Then whilst I remain 3, J equals 1, J equals 2. So that is exactly how for loops actually work. So in the future, if you happen to be coding, you should take notice when you're actually creating nested for loops. Now again, we do have some keywords in R, which happens to be break, and then we also have the next. And what actually happens is this one will break the loop. It actually breaks the loop. And then the next here will skip the current iteration. Okay, so break is going to end the for loop or whatever loop that you are doing. It could be for loop, while loop, but we are here to cover the while loop. and then next year is going to skip that current iteration. Now let me show you how that actually works. A very simple thing. So we're just going to do that in one or two loops examples, and then we move on to the next one. So we are going to go ahead and say for I in 1 to 10, like this. So what do we want to do with each I that is found in each item of this collection? We would want to bring a conditional statement, and we have done that before. So if, all right, so we're going to say if I equals 5, then we also open another set of curly braces, press enter. Within it, we are going to now do something when this condition becomes true. So I'm just simply going to go ahead and say break. So actually, you see what is actually happening? I'm saying that, okay, now let me highlight this part of the code and cut it. I'm going to paste it again, and I'm going to show you why I did that. So first of all, from this for loop, I in 1 to 10, what do we want to do with each value? So we just simply want to print the I. Then before the print, I'm now going to insert the if condition. I hope you now get it. So first of all, you are going to loop over for I in 1 to 10. We want to print each value of I, which of course is gonna be like this. So let's clear the console and execute. So it's going to print every single element that is found in the collection, 1 to 10. But then before it prints each value, we want to check a condition before it actually goes ahead and prints what we wanted to do with the I in the for loop. So if the I equals 5, then break the loop. That is very simple. Break the loop. It is a reserved keyword, and so you can use it this way. So now let's see what actually happens. For I in 1 to 10, I is going to assume the very first value, which is 1. It checks again. 1 equals 5. No. Therefore, it jumps over this conditional execution because it is false and goes ahead and prints that value I, which is going to be 1. Then I is now going to take the second value in the collection, which is 2. And then 2 is compared to 5. 2 equals 5, false. So it jumps over this break statement until 5 equals 5, and then that condition becomes true. This break will actually break the for loop. So it wouldn't print 1 to 10, it will print, let's check, 1 to 4. So when it is 1, this condition was false, so it goes ahead to print it. When it is 2, it is still false, 2, 3, 4. Then as long as I equals 5, then it becomes true, then it breaks and doesn't even bother to go to the print I to continue the for loop. So use break here to break your loop. Then for the next, this is also how it actually works. And I'm going to also write for I in 1 to 5. Then what do we want to do with the I? We also want to go ahead and print the I. But then before printing the I, we want to check a conditional execution, a conditional statement to see if I equals 3, then go ahead and next. So next is also a keyword to do the control flow. You could see that the label actually appeared in RStudio. So if you go ahead and write this, you can see that is the control flow, and they are all reserved keywords. That is actually what I wanted to show you. So now if I go ahead and execute this for loop, let's see what actually happens. So we want to print each element in this collection, which is 1 to 5. But then when I equals 3, we just go ahead and say next to skip that iteration. And you can see that 1, 2, 3 is nowhere to be found, then 4, 5. So that is actually what happens. So let's go back here. The break will break your loop, and the next will skip the current iteration. And there is also one thing that I want to show you. If you recall, when we went up here, we use 1 to the length of numbers. Now, there is another function that is available in R to make things very simple. And that function is, instead of using 1 to length, if it makes it too complex for you, then you could also use an alternative using what we call sequence along, like this, sequence along. So it's a function that is available in R, sequence along. And if we should check the documentation, it is sequence generation. So it generates regular sequences like this. Eventually, we're going to learn something that we call data management, and we'll learn some of these functions like the sequence and the format and all of those things. Many functions are actually coming up in data management, so look out for that particular lesson. But this one actually generates sequence. So what is going to happen is I'm going to put the numbers as a vector in there. So here I would say numbers. So you know what is going to happen? Remember, if we go ahead and print numbers in the console, it is 10, 20, 30, 40. If I now say sequence along numbers, it's just going to count 1, 2, 3, 4. So it's going to generate a sequence equal to the number of elements in the vector 1, 2, 3, 4. Just like you would do with 1 to the length of numbers, which also generate the same thing. So instead of using 1 to the length of something, you could go ahead and use sequence along very simply. And if you go ahead and execute this, so for example, if I execute for I in 1 to the length of that, remember we had index 1 value 10. And if I also go ahead and execute this code, we'll end up getting the same result. So there is no difference between that. So instead of using 1 to the length of the vector, you could go ahead and use sequence along, which will shorten that for you. If it looks short to you, you can actually use it. If it doesn't, go ahead and use the 1 to the length of the vector. One last thing before a major exercise, and then we bring this lesson to a close. The for loop is one of the lessons that students actually find difficult. That is why I'm taking time to explain all of these things, and you would be very comfortable with doing loops in R. So you can also go ahead and grow objects in R. So you can grow objects inside loops in R, okay? Let's do that. Okay, so I'm going to go ahead and create an empty vector. And in this case, I'm going to call the variable result like this. And if I go ahead and execute this and print result, you would see it is null. Nothing is in there. All right, so we are actually going to take this empty vector and we are going to populate it using for loop for each item we do in a particular collection. So I'm going to say for I in 1 to 20, I actually always use the I. So let's go ahead and change it and use something else. So let's say for value in 1 to 20, just like I said, you can name it however you want. So for value in 1 to 20, then what do you want to do? I'm just going to go ahead and say, let's take the vector which we have named as result, and I'm going to index it. And so that means I'm calling out each element in that vector. For now, it is empty, but I'm still going to index it. So for example, if I come here and say result square bracket and I put in 1, it is still null because the whole vector is null, right? But I'm going to put in value. So just like we did here, result square bracket 1, this is also going to be value is going to assume the first value in the collection, which is 1. So instead of value here, it's going to be 1. But remember, that will return null. So let's go ahead and maintain it as value. Now, value will also be the second item in this collection, which is 1 to 20. So the second item is going to be 2. So this value will now be replaced with 2, like that. So all that we are just trying to say is that if, for example, value equals the first item in the collection, which is 1. So if we have 1 here, like this, then we should go ahead and assign. So it means that the first item in this vector, this empty vector, should be what? It should be the value squared. So value is going to assume the value 1. So value equals 1. Then that 1 gets deposited here. That means this value is also going to be 1. So it's going to be 1 squared, and that would give you 1. So it means that the result, the first value in this particular vector is just simply going to be 1. Then value is going to take the second item in this collection, which is 2. So now here is going to be 2, and here is also going to be 2. So it means that the second item in this particular vector should be 2 squared, and that should be 4. Then value is going to take the third item in this collection, which is going to be 3. And 3 squared is going to be 9. So the third item in this particular vector should be 9. That is exactly what we are doing. So I think you get a point. So now let's go ahead and change this one to value and change this one to value so that the for loop will do the iteration for us at once. So we can now go ahead and click on run, and that has worked. But this time, let's go ahead and print our results. So let's see what we have here. So is our result still empty, or does it have the square of every single value in the iteration? Exactly. So you can see that the result has been populated with all of these values. But sometimes growing some of these things inside of loops, it's much better to use what we call vectorization. So if you have a vector, so let's call this one results underscore 1, which is a different variable name. And then I'm going to actually create a vector from 1 to 20 like this. So let's go ahead and run this and print result 1 like that. So we have 1, 2, 3 all the way to 20. So simply we could go ahead and say results underscore 1 square. So we are taking the whole vector and then square. So when that happens, remember when we learned the vector operations, arithmetic operations on vectors, vector by vector operations, that is exactly how we learn this. So each element in that vector will be squared. And when we do that, we get the same result. So you can see that vectorization is much simpler. And if that happens, you could do it this way, or you could actually grow it inside of for loops. Now let's go ahead and have an exercise. So this is going to be the exercise. Let's go ahead and break it in multiple lines, and then let's now comment this. So given numbers from 1 to 20, use a for loop to check if each number is even or odd. And then you go ahead and print the result. So let's go ahead and do this. So now we are going to create our for loop and say for I in 1 to 20. So for every single item, I that is in this collection 1 to 20, what do we want to do? So given the numbers from 1 to 20, use the for loop to check if each number, so each I, is even or odd. And then you print the result. So I am now going to check if, and once we have this statement coming out, we use the if conditional function. So if, and then after that, we bring a set of curly braces, and then now within the if function, we go ahead and write our condition. So if you want to check that a number is even or odd, remember we use the modulo operator. So I'm going to say I modulo 2 equals 0. So it means that, for example, 5 modulo 2 is 1. That means 2 would actually go into 5 2 times. So 2 times 2 gives you a 4 with a remainder of 1. So the modulo operator returns a remainder. So we are saying that, remember, if the number is odd, it returns a remainder of 1. But if it is even, it returns a remainder of 0. So for example, 6 modulo 2 would give you 0. So if the number modulo 2 returns the remainder as 0, it means that that number is even. So let's go ahead and now use the concatenate and print function and print something much more meaningful. So I'm going to say I, and then let's have is even. So if I modulo 2 returns a remainder of 0, go ahead and write the number I, and then say that number is even. And remember, when we use the cut function, let's go ahead and insert a new line. Otherwise, it's going to put every single thing on one line. So I is even. And then we would now initiate our else keyword. Press enter, and within the else body of the conditional execution, we'll also go ahead and then we would say that I is going to be odd. At this point, we don't need to write any other condition again, because once the remainder is not 0, it will move to the else block and go ahead to print whatever execution that we want to do with the code right here. So now we are done. It's just a very simple exercise. If we should go ahead and, oh, come on, we just simply want to insert new line like that. Very beautiful. And if we go ahead and run this, boom, for every single number, so for I in 1 to 20, so I is 1, I is 2, I is 3, all the way to 20, and then it checks within the conditional execution to see whether it is even or odd. So if we now look at the result, 1 is odd, 2 is even, 3 is odd, 4 is even, 5 is odd, 6 is even, like that. Very, very simple. So this is how you can actually create for loops in R.